students, a very warm welcome to Ritu Maths classes. Today we are going to take up the topic of a pair of linear equations and two variables, and it's from class 10th, chapter 3. We are going to take some questions from the optional exercise 3.7. For example, I've taken 7th question, first part, and it is considered to be very important from the board examination point of view. As you can all see, the two linear equations have been given to us, and we have three methods to solve for. First is elimination, second is substitution, and the third is cross multiplication. We can solve this pair with any of the methods, but looking at the equations, I think elimination is the best suitable method. This intuition of getting which question to be solved for by which method comes with the practice only, or if it is asked in the particular question, the particular method's name is given, so you have to apply that only. For that, I have put up another videos on the same channel, so if you want to go for a substitution method or cross multiplication, you can look up to those videos. Here I am going to use the best suitable method, that is elimination method. So if you like my video, keep watching till end and do not forget to subscribe my channel. Let's start with today's question. Write down the solution. I have been given these two linear equations which I will mark as first and second. I've just given them a reference of number 1 equation and number 2 equation. I'm going for elimination method, which is also known as the eliminating the variables. How to eliminate? By equating the coefficients. For example, here I have the coefficient of x as p and the coefficient of x as q in the two respective equations. So in order to equate them, I have to multiply the whole first equation with q and the whole second equation with p, so that when I multiply the whole first equation with q, it becomes pqx plus q into q, that is q square y, is equal to pq minus q square. I have to multiply each and every term with q. Similarly, multiplying the whole equation, second equation, with p, I get pqx minus p into p square y, is equal to p square plus pq. As you can all see, the coefficients of x have been equated over here and they are of the same sign, positive. So we should go for subtracting the equations, so that when I subtract them, one pqx is positive and another pqx is negative, which cancels out. And now I have to solve for the rest. It is q square y plus p square y on the left hand side. Right hand side, pq minus q square minus p square minus pq. pq minus pq again cancels. On the left hand side, I have a common factor y, so I have taken it common. On right hand side, I have taken a negative common because both the terms remaining are negative, so I can take the negative out. The whole factor q square plus p square is cancelled out, so I have got the value of y as minus 1. When you get any one variable, you have to put it back in any of the equations given. So I am going to put this value in number 1 equation. Wherever I will find y, I will replace it with minus 1. Let's start. Px plus q into y. So y is to be replaced by minus 1 is equal to p minus q. Let's simplify. This gives us only px is equal to p, that is x is equal to 1. So these are the values of the required variables x and y. So that's the answer of this equation. Let us continue with this practice of our elimination method with some more questions. So I have taken the same 7th question, third part. it will give you more practice of the same method, elimination method, which is the most usable, most widely used method, you can say. Let's start with this question. I have been given this pair of linear equations, but as you all see, the very first equation is not in the integers, it is somewhere in fractions. So I'm going to sort out the first equation first of all. So I'm going to take the LCM. You can see bx minus ay is equal to 0. That gives you bx minus ay is equal to 0 into ab, 0. So this is the third equation. So now I'm going to solve for second and third. As you can see, second and third equation, the coefficients of x can be easily equated if we multiply the second equation with b and third equation with a. So that the equations become abx plus b into b square y is equal to b into a square plus b square. The whole equation should be multiplied with the same number. Okay. Let's multiply the third equation with a. It becomes abx minus as such a into a square y is equal to 0 into anything is 0. As you have seen that the coefficients of x have been equated and they are of the same sign, positive, positive. So we must go for subtraction. So that when we change the signs, abx positive cancels with abx negative. And we are left with b square y plus a square y on LHS is equal to b into a square plus b square. Minus 0 doesn't matter. So that in the next step, when I take the common factor out from LHS, that is y, I am left with b square plus a square into y is equal to b into a square plus b square. The whole factor cancels again and I'm left with a very simple value of y, that is b. As you all know, once I get the value of a variable, I just put it back in any of the easy equations. So you can put it in second or third. I'm going to put in third as it is comparatively easier because we have got 0 on RHS. So let's put it up. Bx as such minus a into y is to be replaced by b is equal to 0. That I have got the value. So it gives us x is equal to a. Another simple value of the variable, and that is the answer for these equations. If you want to verify these answers, you can put back these answers in the given equations and check whether the equations are satisfied or not. If the equations are satisfied, when I mean to say satisfied, it means the LHS and the RHS should be same. So you can go for verification in the end, or you can go for verification in the rough work for your own satisfaction. Okay. So we will be continuing with more questions. Let's start with another. Let's start solving question number 8 of the same optional exercise 3.7. ABCD is a cyclic quadrilateral. What is a cyclic quadrilateral? A quadrilateral whose all the 4 vertices lie on the boundary of a circle. That is a cyclic quadrilateral. Fine. Find the angles of the cyclic quadrilateral. So we have to find out each angle. Angle A, angle B, angle C, angle D by solving. So first of all, we are going to use a property of the cyclic quadrilaterals. Since the opposite angles of a cyclic quadrilateral are supplementary, this property you have done in your 9th class. This means to say the sum of the opposite angles will be 180 degree. So that gives us angle A plus angle C is equal to 180 degree and angle B plus angle D is equal to 180 degree. So because we are not given the linear equations directly, so we have to make it. Let's frame the linear equations. I'm using angle A plus angle C is equal to 180. First of all, angle A, 4y plus 20 plus angle C, Angle C is minus 4x. This sum should be 180. Let's simplify. 4y plus 20 plus minus 4x. As you all know, we always keep the term containing x first of all, and then the term containing y, and then the constant term. So it can be simplified this way. Minus 4x plus 4y is equal to 180 minus 20 gives you 160. If you want, you can simplify by taking a common factor 4 out. It's totally up to you. Okay? And angle B plus angle D. 3y minus 5 plus angle D minus 7x plus 5 is equal to 180. This gives us 3y minus 5 as such plus minus 7x plus 5 is equal to 180. Minus 5 plus 5 cancels down. So we are left with minus 7x. The term containing x is to be written down first of all, and then the term containing y should be equal to the constant. Now we have framed the linear equations. We have got two linear equations in two variables. Let's simplify. I will be using the elimination method. So let's simplify these by elimination. Elimination means we have to equate the coefficients. So as you all can see, here I am having 4y and here I am having 3y. So I'll be multiplying the first equation by 3 and the second by 4. So that I get the coefficients of y as the same, 12. Let's start multiplying. Minus 12x. The whole equation is to be multiplied by 3. Remember it, okay? Plus 12y is equal to 16 into 3, 48, 0 as such. Let's multiply this with 4. Minus 28x plus 4 3s are 12y is equal to 720. When we equated the coefficients of y, we must check if they are of the same sign, we should go for subtraction. So that when we subtract, we change the signs throughout, and when we change the signs throughout, the terms containing y cancel with each other. 12y minus 12y. So this eliminates the coefficient. That's why this method is known as the elimination method. Let's simplify this. Minus 12x plus 28x. So actually 28 minus 12, that is 16x is equal to, here you have 480 minus 720. So you have to subtract 720 from 480. That is 720 is a bigger number, so negative sign will be there, 0 as such, and then you can take the difference. That comes out to be minus 240. So x is equal to minus 240 divided by 16. Common factor 4 and then again 4. That gives you x is equal to minus 15 degree. This value is to be put up in any one of the equations. Whether you can put it in number 1 or you can put it in number 2 as you feel like. So I am going to put it in number 1 equation. Let's simplify. I'll be getting minus 4 into minus 15. X is replaced by minus 15 plus 4y is equal to 160. Let's simplify for the values of y. Minus minus plus. 4 15s are 60. This becomes 4y is equal to 100. That gives you y as 25. Now I have not been given the values of x and y as such, so I have to solve for the angle. I have been asked to find out the angles. So please remember to solve the angles in the last. Don't forget this step. Angle A is equal to 4y plus 20. As you can see in the figure, this is the value of angle A. Y is to be replaced by 25. 4 into 25, 100 plus 20. This is 120 degrees. Angle B, 3y minus 5. 3 into 25 minus 5. 25 3 is 75 minus 5, 70 degree. Angle C, minus 4x. Minus 4 into x is to be replaced by minus 15. Negative, negative, positive, and it is 60 degree. And the last, angle D, minus 7x plus 5. I'm going to replace x by minus 15. 15, 7s are 105 plus 5, 110 degrees. That's the final answer. So if you want to verify the answer, you can just add the opposite angles, angle A plus angle C. 120 plus 60, 180. Yes, it's fine. Angle B plus angle D, 70 plus 110, 180. Because as I mentioned in the beginning of this question, this is a cyclic quadrilateral. So opposite angles must be supplementary. So that verifies our answer. And one thing more you can do, since it is a quadrilateral, so the sum of all these four angles should be 360, which is coming out very easily. Okay, so let's continue practicing more questions of elimination, and if you have any doubts, you can let me know in the comment section. Thank you for watching the video, and please do not forget to subscribe my channel. Thank you.